Hello, my lovely first years. How are you doing? I hope you're all staying safe and well. Um, you haven't had much science work to do, but don't worry, I'm here to fix that. So we are going to move on to chapter 19, which is separating mixtures. So the first thing is a bit of revision. What is a mixture? And you should remember this from our chapter on elements, compounds and mixtures, that a mixture is two or more different substances mingled together with each other but not chemically combined. So they're mixed together but they're not stuck together. We can separate them again. And in this chapter, we're going to look at some ways to separate the mixtures in order to produce a pure substance. A pure substance is one that contains one substance only, so it has no impurities in it. So you wouldn't drink water that has some dirt in it because you know it's not pure water. It has impurities, it has dirt in it. So a pure substance must be an element or a compound. It's not a mixture. So for example, pure water would be just H2O, would just have those water molecules in it. It wouldn't have anything else. So looking at these, so first of all we look at the molecules here. So is this a mixture or a pure substance? You can tell that there's only one type of molecule there or element, so that must be a pure substance. What about the second one? So the purple ones. Is that a mixture or a pure substance? Hopefully you can see from that it's pure. It has one type of element or molecule only. Lastly, up there we've got this one. So that, how we would describe it is that it's a mixture of green and purple spheres. That's what we would say if we were talking about in English, that you had to describe it. And that's exactly what it is in science as well. It's a mixture. There's two different substances. They're mingled together. They're all mixed up together, but they're not joined together. They're not bonded. So those are two pure substances, and then the mixture when they're all mixed together. Some other ones down in the bottom left, we've got oxygen that would be used in hospitals. Do you think that's a mixture or a pure substance? It would be a pure substance because it needs to be pure oxygen that they're giving to their patients. What about the picture here of the sea? So first of all, we've got clean air. So don't let the word clean fool you. Air is a mixture as well. Air is a mixture of all the different gases that are in it. Maybe you can name some of them yourself. We know oxygen is in air. Do you know any of the other gases that are in air? It's a mixture of all of them. And what about seawater? Have you ever been in the sea and tasted some of the water? Does it taste like normal pure water? It doesn't, because it has a salty taste because there's lots of salt in it, and there's lots of other substances in there too. And lastly, we've got bottled water. If you can find a bottle of water at home, and if you look, there's actually on the label, there is a list of ingredients. It might not say ingredients, it might say the composition or the mineral composition, because your bottled water isn't actually pure water. It has calcium, magnesium, sodium, potassium, all these different things in it. So bottled water isn't pure either. It has other substances dissolved in it. Last week, the work you did, you looked at solubility, which is the mass of a substance in grams that will dissolve in 100 grams of solvent at room temperature. So the solubility is how much of it will dissolve in a certain amount of solvent. So when a substance dissolves, what that means is that it becomes incorporated into the other substance. It becomes a part of the other substance. Think about it. If you put a spoon of sugar into a cup of tea, can you still see the sugar? Can you take the sugar back out? You can't, not unless you've put in so much sugar that it starts to not be able to dissolve anymore because too much of it has gone in there. Then you'd get some at the bottom of the cup. But usually if you just put in 1 spoon of sugar, The sugar looks like it disappears, but it doesn't. The word is it dissolves. It becomes part of the tea mixture. So it has dissolved into the tea. Soluble versus insoluble. So hopefully you've heard of these words before. If a substance is soluble, it means that it will dissolve into another liquid. If a substance is insoluble, it won't dissolve into a liquid. So today we are going to look at ways to separate soluble and insoluble substances from a liquid. So again, soluble, they will dissolve like the sugar into the tea. Insoluble, they won't dissolve, and I'll show you an example of that now. So some of these, if we look at the pasta one in the middle first of all, is pasta soluble or insoluble in water? When you put pasta into a pot of boiling water, does the pasta disappear? And I'm saying that with quotation marks. Does it become incorporated into the water? Does it become part of the water? No, so it's insoluble. You can still see the pasta and you can remove the pasta easily from the water. We looked up in the top left, we looked at the sugar example already. So we know that the sugar will dissolve in the tea, so that makes it soluble. Up in the top right, we've got salt that has been added into water. Is it soluble or insoluble? Hopefully you can recognize that it's soluble. The salt has become part of the water solution to make a mixture. Down at the bottom, we've got a vitamin C tablet that's fizzing up into the water. After a couple of minutes of that, what you would see is that it looks as if the tablet has dissolved or disappeared. And what has actually happened is it has dissolved. It's made a mixture with the water and it's become a solution. So it's dissolved into it. And then just a fun one for you. Are humans, are swimmers soluble or insoluble in water? We would say for the most part they're insoluble. We haven't really seen anybody dissolve into the water, have we? So let's look at the pasta for a second. We said that it's a mixture of an insoluble substance, the pasta, and a liquid. And the liquid we're looking at is water. So we've got insoluble pasta in the water. How would you separate that at home? Hopefully you would strain it. So we would use a colander like the pretty little blue one shown here. You would strain it and that will separate the water from the insoluble substance. We do a thing similar to this in science and we call it filtration. So that's what we're going to look at now. So filtration involves separating, this is your definition, sorry, up at the top in black. Filtration involves separating an insoluble substance from a liquid using a material that will allow the liquid to pass through but not the solid. And what we use in the lab is we use filter paper, this in the orange box up here on the right. We have filter paper that it has loads of tiny, tiny, tiny microscopic holes in it. So it will allow the water to pass through, but it won't allow the solid to pass through it. I put in another example here because it seems up to date with the times. Another example of filtration is a face mask. So a lot of people are wearing these at the moment. And the reason for that is that the face mask is like filter paper. It has lots of holes, lots of small holes in it to allow air to pass through so that you can still breathe in, but it stops or traps the germs. So looking at the filter paper here, I've tried to make a little picture to show you that so down here, this is the grey bits here, that's the filter paper. And that's the filter paper really zoomed in on. And what you can see is the tiny particles of water or liquid are able to pass through the tiny holes, but these brown bits that are the solid, they're too big, they can't pass through. So your filter paper has lots of tiny holes in it that are big enough to let the liquid pass through, but they're too small for the solid to pass through. So how do we do this in the lab? We get our conical flask down here and we place the filter funnel into it. And we get our filter paper and we fold that up to make it into a cone shape, and we sit it inside here in the funnel. And then what we can do is we can take our liquid that has the insoluble solid. So obviously in the lab we're not going to be separating water from pasta, but we might have to separate water from sand if we were doing an experiment on beach water or something like that. So we've got the liquid and the insoluble solid, and we pour them in through the filter paper. Now, as you might imagine, this has to happen slowly because it takes time for the water or the liquid to filter out. And so we only do it slowly because the filter paper is very thin and we don't want to overload it. We don't want to break it. What else do I need to say about this? Oh yes, so once you've finished filtering, so once all of that liquid and insoluble solid have gone through, what you'll be left with is you should get the liquid out down at the bottom, and this is called the filtrate, and you'll be left with the solid here in the filter funnel, and that is called the residue. So you might have heard of the word residue in some other circumstances, and a residue is something that's left over. And so the solid is left over in the filter paper. So just to define those, so these are your definitions that you need. The solid remaining in the filter paper, that's going to be called the residue. So the residue is in purple here. And the filtrate, I'll put in blue, the filtrate over here is the liquid that is going to pass through. You need to know those definitions. So now let's go back and look at the salt water. So if it is a mixture of a soluble substance, the salt, and a liquid, how would you separate it? You couldn't use filtration because this time we have got a soluble substance. So it's not, the solid isn't, we can't see the parts of the solid in the water. We can't see the parts of the salt. They've all dissolved and become part of, they've incorporated into the solution. So how we would separate it instead is we would use evaporation. So we would heat it up. So here in my second diagram, the yellow particles are all the water particles and the red dots, they're all the salt. And so if we heat it up, if we apply heat to the glass, what will happen is the water will start to evaporate off. It will start to boil if we're heating it up. All the water particles will evaporate off, so they'll turn into a gas and they'll go and spread out around the room. And you'll be left with only the salt. So here we've only got the salt particles left. Now, as we said, that's called evaporation. You'll remember this from our solids, liquids and gases chapter, that evaporation is the changing of a liquid into a gas. So we can use evaporation, like we saw in the salt water example just there. We can use evaporation to separate a soluble substance from a liquid. So in other words, we can separate the solute from the solvent. So other examples here of evaporation that we spoke about back in the last chapter were when you leave paint to dry, when your clothes are drying out in the sun, or when you're boiling the kettle, you can see the water evaporating there. Okay, and in hot countries, they actually use evaporation to get salt from the sea. So they have these special beds that you can see here where the salt water from the sea comes in, and they leave a very thin layer of it there, and what happens is the water evaporates off and all that's left then is the salt. And just for your own information, salt has the chemical name of sodium chloride. So on our periodic table, that would be sodium is Na and chloride is the chlorine ion, which is NaCl. What does evaporation look like in the lab? So there's two ways to do it. This is way number one. This would be putting your solution, so again we're talking about salt and water here at the moment, putting it into an evaporating basin. So you can see the liquid over here, I'm putting it in red. So you put your liquid, the salt and water, into your evaporating basin. Hopefully you're remembering these bits of equipment from the activities and the worksheets that we did at the start of the year. And what we would do is we would place the evaporating basin on top of a beaker of water here, a beaker of water, in order to heat it up to evaporate off the liquid. Now the reason we don't put the evaporating dish directly over the Bunsen burner, where I'm kind of drawing on the outline of it here, the reason we don't do that is that would cause the liquid in the evaporating dish to heat up too quickly, and it could start spitting out the liquid and the salt crystals at you. The same way if you put a pan on the cooker of really hot oil and you put some food into it, it can start spitting out the oil at you. So we don't want that to happen. So then we've got our tripod and gauze here in the yellow box that we used with the Bunsen burner, which is shown here on the right. Everyone always remembers that because it is the one that allows us to get a flame. So that's one way of evaporating in the lab. So we heat up the salt and water in the evaporating basin as shown here on the screen, and we'll be left with the salt crystals, and you can see them starting to form at the edge of the evaporating basin. However, even though that's the quickest method for evaporation, it's not the safest or the best method to get the maximum amount of salt crystals, because like I said, you're going to end up having a little bit of spitting of the liquid happen, which means you might lose some of the salt. So evaporation, as we know, occurs naturally, like drying clothes, or puddles, that when the sun comes out, the puddles and the water in them evaporates off and they become dry. So the best way to evaporate off a liquid is simply to let it sit in a warm place for a few days, and this will allow all of the water to evaporate off and the crystals to form. So you could put it on a nice windowsill that gets lots of sunlight during the day, and that will allow the water to evaporate off. That's the best way to do it. It means you would get a lot more crystals. And if you do it like that, what you'll get is, like you can see in the evaporation dish over here, you can see all the crystals of salt that have formed. So the crystals of salt that you'll get from this are usually quite small, but you can see them here nonetheless. So the result here is that you get crystals of sodium chloride, which is salt, that are remaining when all of the water has evaporated. And the conclusion, what we can tell from this, is that a solution of sodium chloride can be separated by evaporation, a solution of sodium chloride and water. So now that we know all of that, you are now going to do the experiment yourself at home. A little DIY experiment. So we would do it in the lab the ways I just showed you, but obviously we can't go into school to do it there, so you're going to do it at home. So I'm just quickly going to go through the slides with you, but I'll leave this up on Microsoft Teams in the PowerPoint for you to go through yourself slowly at home. So you're going to make your own funnel by carefully cutting the top off of a plastic bottle. I used Evian water, but there are other brands available. I'm not sponsored by them. Step 2 would be to make your own filter paper. Get a piece of kitchen roll or a piece of strong tissue, fold it in half once, fold it in half again to fold it into quarters, and then you can cut it like I did here along the red dotted line, just to make that nice curved shape as if we were using real filter paper. Next, you're going to open up the filter paper like a cone. So you need to have all sides of the funnel covered in the filter paper. So you're going to have, as you can see here, there's going to be a thicker side and a thinner side. So you just need to be very careful not to rip any of it. So before you put that into the funnel, then you're going to dab the inside of the bottle with a bit of water, just so that the funnel can stick to it a bit better. And then you should end up with a picture that looks like this. Now we need to make our solution. So we are going to make a salt water solution, and we're going to add in an insoluble solid as well. So the first thing to do is get a glass and approximately half fill the glass with water. You're going to add some salt to it, not too much, because only a small amount will dissolve in the water. So add in small bits at a time and don't add in too much. Stir it to dissolve the salt. I stirred it so well that my picture turned out blurry. Next, what you're going to do is you're going to add some soil or sand. I would usually add sand in the lab, but since I'm not in the lab, I went outside and I got my hands dirty and got some soil. I just added in a small bit, making sure there was no big lumps and making sure there was no stones in it or little pebbles, because they could rip the filter paper, and I stirred that up as well. So the first real part of the experiment is the filtration. So you're going to set up your funnel on top of a clean glass and slowly pour the mixture in through the funnel. You need to do this slowly because you don't want to overload the filter paper, and you don't want it to be too heavy in there that the filter paper rips. If it rips, you need to start again. You can swirl the original glass, so you can see me over here pouring it in. You can swirl that glass to get out as much of the soil as possible, and to get out all of the water as well. And then compare it before and after. You can see my before is a very muddy mixture. You can see my after looks like you could almost drink it. I won't, because there's salt in it, and I don't want you guys to drink it either, and because there probably is still little bits of dirt in there, but it looks much better. You can see that the filtering has worked really, really well. The next step is the evaporation. You place your filtered water on a nice warm, that should say warm, I've written warm windowsill to allow the water to evaporate. This might take a few days. What you can do to try to speed that up is put it into a dish that has a bigger surface area that can spread out the water more. I've put mine into a bowl, but you don't have to. It'll work just as well leaving it in the glass. It might just take an extra day. And hopefully you'll end up with something that looks like this picture here. Disclaimer, this is not my result. This is from the internet because mine isn't finished yet. When you've your experiment done, or as you're doing it, you need to take pictures of each stage as you're going through them, if you're able to do it. And then you'll complete a report on your experiment. This is really important, and I'll put this on Teams. It needs to have a title, a list of equipment, the method you used, and the results. So all of that is in this PowerPoint for you. You're just replicating it yourself. You might have used some slightly different materials to what I used, so you need to make it your own. There's 3 options here that I'll put on Teams for you of how you can hand this up. You can type it up and send it to me on Teams. You can write your report in your science copy and send it to me with all the pictures, or you can make a poster with the information on it and send that to me with all the pictures as well. Whatever way you would like to do it, it's all up to you.